Hello, dear students. This is the Engineering Mathematics 3 lecture. The topic is Z transform. Last lecture, we have discussed the Z transform of some standard sequences and properties of Z transform. This topic Z transform is from second unit. Now the examples on Z transform. This is the example. Find Z transform of f of k if f of k is equal to 1 by 4 to the power mod k for all k. Now the Z transform of 1 by 4 to the power mod k, Z transform of 1 by 4 to the power mod k is equal to, use the definition of Z transform. Z transform definition is summation f of k into z raised to minus k. K varies from minus infinity to infinity. Now f of k is the sequence 1 by 4 to the power mod k. To put in place of sequence 1 by 4 to the power mod k into z raised to minus k. This is the definition of Z transform. Okay. Now the limits are from minus infinity to infinity because k here in sequence, the power is mod k. Now split the limits minus infinity to infinity as minus infinity to minus 1 and then from 0 to infinity. So when the limits are minus infinity to minus 1, write in summation 1 by 4 to the power k, sorry, minus k, because limits are minus infinity to minus 1. So when limits are minus infinity to minus 1, you take the power of sequence negative minus k. And the term of z as it is z raised to minus k plus second term summation k varies from 0 to infinity and the sequence is 1 by 4 to the power k. Here k varies from 0 to infinity, so you take the positive power of k because in the given sequence the power of 1 by 4 is modulus of k. So you take negative when limits are minus infinity to minus 1 and you take it positive when limits are from 0 to infinity. And the term of z as it is in both the terms. Now to change the limits of first summation, k varies from minus infinity to minus 1. Because when limits are from minus infinity to minus 1, in that case we change the limits because we don't know the value of infinity. And the lower limit is there minus infinity, we don't know the value of infinity. So in this case, we always change the limits. And the substitution, standard substitution is here, put k is equal to minus r. K is equal to minus r, so r is equal to infinity. When k is equal to minus infinity, then the value of r is infinity. And when k is equal to minus 1, r is equal to 1. So in that case, the limits of first summation change to 1 to infinity, r is equal to 1 to infinity. And in the summation, the term is 1 by 4 to the power r because minus k is equal to minus r. So if you put k is equal to minus r, minus minus plus, so the power is r, 1 by 4 to the power r, z raised to minus k. The value of k is minus r, so put k is equal to minus r, so the power of z is r. Okay, so summation r varies from 1 to infinity, 1 by 4 to the power r into z raised to r plus summation 1 by 4 to the power k. Second summation, second term as it is because the limits are positive, 0 to infinity. So no need to use here substitution. The substitution is only for first summation because limits are negative. To change the limits here. Now for the first summation, you put r is equal to 1, then you will get the first term 1 by 4 into z, z by 4. Second term, put r is equal to 2. If r is equal to 2, the term is z by 4 to the power 3. When r is equal to 3, the term is z by 4 to the power 3 and so on. Next summation, put k is equal to 0. K is equal to 0. When the power of any term is 0, then the value is 1. So first term value is 1 plus put k is equal to 1. When k is equal to 1, it is 1 by 4 to the power 1 z raised to minus 1. Z raised to minus 1 means 1 by z. So the term is 1 by 4z plus. In k is equal to 2, the term is 1 by 4z to the power 2 and so on. So this is the series for second summation. And for first summation, first term is the series. Okay. Now these two series are the geometric progression. So use the result of GP. What is the result formula of GP for first series? It is first term upon 1 minus common ratio. Now first term is here z upon 4, so write in numerator z by 4 upon 1 minus common ratio. Common ratio is here z by 4 in every term. So you write here common ratio z by 4. And you know that the common ratio is always less than 1. So you put here the condition mod of z by 4 is less than 1. Okay. This is for first series. Now second term, second series, you this series is again geometric progression. So again use the result of GP. So what is the result? First term 1 upon 1 minus common ratio. Common ratio is here 1 upon 4z. The first term is 1, so we can write this term 1 as 1 upon 4z to the power 0, because when the power is 0, the value of that term is 1. So in every term 1 by 4z is a common ratio. So right here 1 by 4z common ratio, and that common ratio is less than 1. Mod of 1 by 4z is less than 1. Okay. Now simplify the term, which is first term, and you know that Z transform of f of k, we use the notation for Z transform of f of k, f of z, capital F of z. So we can replace Z of transform of 1 by 4 to the power mod k by f of z. It is equal to, now the first term simplification, z by 4 upon 1 minus z by 4. And the condition is mod of z by 4 is less than 1. So you just shift the 4 in RHS so that you will get the condition mod z is less than mod 4. And second term, 1 upon 1 minus 1 by 4z. So here you take 1 by z common, in denominator you take 1 by z common. If you take 1 by z common, the simplified term is here z upon z minus 1 by 4. And the condition for that second term is here 1 by mod of 1 by 4z is less than 1. So you shift this z here in RHS so that the condition will be mod of 1 by 4 less than mod z. So here the condition, combined condition is here. Here, see, for first term, it is mod z less than mod 4. And for second term, the condition is mod of 1 by 4 is less than mod z. So, the complete condition is here, mod of 1 by 4 less than mod z is less than mod of 4. So, this is the answer. This is the Z transform of the sequence. Now, the third example is here. Find the Z transform of f of k if f of k is equal to 1 by 4. 1 by k, not 4. Assuming that k is greater than or equal to 1, means here, assuming f of k is equal to 0 for k less than or equal to 0. Z transform of f of k is equal to Z transform of 1 by k. Here is one correction, that this is not 4, this is the term here k. The term is here k in place of 4. Remember it. Okay. So sequence is 1 by k. Now assume here f of k is equal to 0 when k is less than or equal to 0, because condition for k is greater than or equal to 1. And so Z transform of 1 by k is equal to, you apply the formula of Z transform, it is summation f of k means 1 by k into z raised to minus k, k varies from 1 to infinity, because the condition of k is k greater than or equal to 1. And so it is equal to, now put k is equal to 1, k is 1, so the first term is z raised to minus 1. And k is 2, then the term is 1 by 2, so z raised to minus 1 to the power 2. When k is equal to 3, then it is 1 by 3 into z raised to minus 1 to the power 3, and so on. This is the series. And so it is nothing but the minus log of, in bracket, 1 minus z raised to minus 1 term. Okay. Now you know the series. Why it is z raised to minus 1? This series is minus log of 1 minus z raised to minus 1 because of the results. Log of 1 plus x is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus so on. Log of 1 minus x minus x square by 2 minus x cube by 3 minus x raised to 4 by 4 and so on. So we are using the second formula here. Z raised to minus 1 plus z raised to minus 1 by 2. Z raised to minus 1 whole square upon 2 plus z raised to minus 1 whole square upon 3 and so on. So in place of x, the term is here z raised to minus 1. And all the terms are positive, so you take minus sign common, and so remaining term is nothing but log of 1 minus z raised to minus 1. Now the fourth example is find the z transform of f of k if f of k is equal to 2 raised to k upon k factorial when k is greater than or equal to 0. Again use the definition of z transform. Z transform of 2 raised to k upon k factorial is equal to summation 2 raised to k upon k factorial into z raised to minus k. K varies from 0 to infinity. Okay. Here f of k is 2 raised to k upon k factorial. Now you take k common. So the term is here 2 into z raised to minus 1 to the power k upon k factorial. K varies from 0 to infinity. Now put k is equal to 0. K is equal to 0. When the power is 0, the value of term is 1. So 1 upon 0 factorial plus 2z raised to minus 1. K is equal to 1. 2z raised to minus 1 upon 1 factorial plus 2z raised to minus 1 to the power 2 upon 2 factorial plus so on. Okay. So what is this series? This is a series and it is nothing but it is the series of exponential function e raised to x. E raised to x formula is 1 upon 1 plus 1 upon 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So in place of x, the term is here 2 into z raised to minus 1. So it is e to the power 2 into z raised to minus 1. And e to the power 2 into z raised to minus 1 means 2 upon z raised to minus 1 means 1 by z. It is e to the power 2 by z. Okay. This is the transform of the sequence 2 raised to k upon k factorial when k is greater than or equal to 0. Now find the transform of f of k if f of k is equal to sin a k upon k greater than 0, strictly greater than 0. So here find the z transform of f of k if f of k is equal to sin a k upon k when k is greater than 0. Okay. Now the sequence is sin a k upon k when k is greater than 0. Z transform of sin a k upon sin a k is equal to the formula of Z transform of standard sequences. Z transform of sin a k is nothing but z into sin a upon z square minus 2z cos a plus 1. So here Z transform of sin a k upon k, use your division by k property. It is nothing but integration over z to infinity 1 by z into sin a upon z square minus 2z cos a plus 1 dz. So integration over z to infinity, z get cancelled. So the term inside the bracket, inside the integral is sin a upon z square minus 2z cos a plus 1 dz. Now sin a is a constant term, so you take it common because it is a constant term. Remaining term is integration over z to infinity dz upon z square minus 2z cos a plus 1. You can replace this one by sin square a plus cos square a because the value of sin square a plus cos square is 1. So the denominator term is z square minus 2z cos a plus cos square a, and it is nothing but a perfect square. So we can replace this term here in denominator z minus cos a whole square plus sin square a. Okay. Now sin a as it is. Now what is the integration of dz upon z minus cos a whole square plus sin square a? Here the integration of 1 upon z minus cos a whole square plus sin square a. Its integration is, you use here the formula integration dx upon x square plus a square, and the formula for integration dx upon x square plus a square is 1 upon a into tan inverse x by a. And here the in place of a square, the term is here sin square a. So use here the formula of sin a as it is in the bracket 1 upon sin a, 1 upon a into tan inverse x by a. In place of a, the function is here sin a, 1 upon sin a into tan inverse z minus cos a upon sin a, and the limit z to infinity. Okay. Now put the upper limit infinity. If you put upper limit infinity, here the sin a into 1 upon sin a, it gets cancelled. Upper limit is infinity. If you put z is equal to infinity, it's tan inverse infinity. Tan inverse infinity minus tan inverse lower limit is there. So we give minus sign for lower limit and replace z by z. So tan inverse z minus cos a upon sin a. After replacing the lower limit, the term is as it is because we are replacing z by z. So the second term is as it is. Now the value of tan inverse infinity is pi by 2. So tan inverse infinity is equal to pi by 2 minus second term as it is tan inverse z, tan inverse of z minus cos a upon sin a. The answer for the transform of sin a upon t. This is now the transform of sin sequence sin a, and then using division by k property, the transform of sin a upon t. Similarly, you can solve the example here. Find the z transform of f of a. F of a is equal to a of a is greater than or equal to the transform of this a when a greater than or equal to 1 is equal to 2s k. You first find the z transform of 2s k, and then using division by k property, you get the z transform of 2s k of k. So here f of k is 2s k. Session is over. Thank you.